Hello and welcome to my YouTube channel. Today we are going to see how to solve the system of linear congruence as you can see on the screen using the Chinese remainder theorem. Now before we dive into the solution, if you are new to my channel, kindly hit the subscribe button right there. This one is more important to me as a content creator. This will also encourage me to continue creating more wonderful content for you. Please kindly hit the subscribe button and turn on the notification bell if you have not yet done that, so that anytime I upload new content, you'll be the first to be notified and not miss out anything. Now, after watching this video, make sure you share, like and comment. These ones will also help me to know what you really want, and also share your recommendation in the comment section, and this will equally help me to improve in the next video. Now before we go into the solution, I would like us to have a review of what the Chinese remainder theorem is all about, the statement actually. Now we have this. The Chinese remainder theorem, as you can see, it states that suppose M1, M2 up to all the way to Mn are all pairwise relatively prime, that is the greatest common divisor of Mi, that is Mj, is equal to 1 for all Mi, for all the i's different to j. That is, if you pick any pair of these m's here and look for the GCD, that's the greatest common divisor, you will find it to be 1. That is a condition. If this condition is not verified, if it does not hold, you cannot use a theorem directly. Now if that holds, then the system of congruence equations like this, as you can see, has a unique solution modulo M1, M2 all the way to Mn. So actually, when you have a system, or this is what the theorem is saying, if you have a system of congruence equation like this, to solve using the Chinese remainder theorem, you have to ensure that the GCD of any of these pairs here, M1, M2, you pair it, you find the GCD, make sure it is 1, and do it for all the pairs, all the possible pairs of the m's, as you can see here, the moduli. If you find that it is 1, then our solution will be unique and it will be congruent to what? M1, the product of their moduli. So now let's see how we can use this to apply to solve our desired question. Moving now to the presentation proper. We have the solution as follows. I'll begin by numbering the equations, equation 1, equation 2 and equation 3, as you can see on your screen. Now from equation 1, we have that x is equal to 2t plus 1, where t is an integer. Yes, an integer. Now look at this, x is congruent to 1 mod 2. It actually means that the remainder when x is divided by 2 is 1. So this can be rewritten using division algorithm, that x, which is our number, will be equal to what? The divisor times the quotient, which of course is known to be t in this case. Since we don't yet know x, we call it a certain constant, plus 1. And this t can be any integer depending on the value of x. Okay, that's what we have. This is basically what you can transform to a simple equation like this. Now we are going to take this one and replace in equation 2. That's basically the next step. So replacing in equation 2, we are going to get 2t plus 1, that is for x, you replace there, is congruent to what? 2 mod 3. This square bracket denotes the modulus function. Now, going forward to simplify, when we have 2t plus 1 congruent to 2 mod 3, it simply means that the remainder when 2t plus 1 is divided by 3, this 3 here is 2. That's what it means. The remainder is 2, what you have here. So, applying division algorithm again, we're going to have what the number is equal to what? 3 times, that's the divisor times the quotient that we get. And our quotient in this case is not yet known. Since we don't yet know the number, so we can denote it by a certain b, and b can as well be an integer. Plus what? The remainder. That is division algorithm that I applied here. Going forward, to simplify, you can just send this one this way, because our goal is to solve for t. Because see that in this equation here, it has a t. My goal now is to simplify to get t. So 2t is equal to what? 3b's plus 1. That's the next step. Now from here, looking at this equation here, we will find out that 2t is equal to 3b's plus 1. So recurring the division algorithm, now we can write it as a modulus, a linear congruence equation. Look at it. This is a number. If you call this a divisor and this is a base, the quotient, then we'll have what? This is the remainder. So 2t, the remainder when 2t is divided by 3 is 1. So we'll have 2t is congruent to what? 1 mod 3. Now, my goal now is to solve this linear congruence. It's not like dividing both sides by 2. No, you don't do that. But this is what we do. When using the modulus, when we are solving linear congruence equation to isolate a variable like this is what you do. You simply multiply both sides of this equation. Okay, let's get back, continue. So what we are going to do here is to multiply both sides of this equation by what? The inverse of 2 in mod 3. That's the number that will multiply to 2 to give us the multiplication, the identity element 1 here in mod 3. So we see that if we multiply the inverse on both sides, this one will change to a 1. This is not 2 to the negative 1. This is 2 inverse in mod 3. What's the inverse of 2 in mod 3? The number that you multiply to 2 and it will give us 1 in mod 3. That's what we want to look for. Now, you know that when you multiply 2 by 2, it gives us 4. And 4 is congruent to 1. The remainder when 4 is divided by 3 is 1, right? So 4 is congruent to 1 in mod 3. So it means that 2 is a multiplicative inverse of this 2 in mod 3. So that if we do that now, so if we multiply here by the 2, this one will just give us our t, which is congruent to what? Since the multiplicative inverse is of 2 in mod 3 is 2, so we have 2 times 1 giving us 2. And we can rewrite this using division algorithm again. That will give us t equals to 3k plus 2, where k is also an integer. Recall what we did here. I just applied the same thing. This is what? The number. And this number, when divided by 3, the remainder is 2. So we transform it to this equation, and now we get that. Now, since we have already gotten t, we can now come back to this equation up here and replace the value of t there. So doing that, I have 2 into what? X equals to 2 into 3k plus 2 plus 1. Now, when we simplify that, it will give us 6k plus, that is 4 plus 1, 5. We have that. Now, after getting all this, that's it. So, now that we have x equals to 6k plus 5, we are going to do this. We now take this x and replace in equation 3 because we want to solve the 3 equations simultaneously. So the next step, we replace equation E in equation 3, we are going to get 6k plus 5, that's for x, is congruent to what? You just replace to 3 mod 5. Now, similarly, this is a number, this 6k plus 5 congruent to 3 mod 5 means that 6k plus 5, when it is divided by 5, the remainder is 3. So this number will be equals to what? Will be equals to 6k plus 5 equals to what? 5d is plus 3. So this d is just a quotient that we get when 6k plus 5 is divided by 5, and our remainder is 3, and d is an integer. Now, simplifying that, we get 6k equals to what? 5d minus 2. Now, similarly, if you want to transform this to a congruence equation, we have that what? 6k is congruent to negative 2 in mod 5, because this is the remainder. Negative 2 here is now the remainder when 6k is divided by 5. Remember, d was just our quotient in that case. Now, after doing that, we know that when we have a negative number in a particular moduli, then we can add the modulus to that, the moduli. We can add the moduli to it and to give us the corresponding congruence. So negative 2, I'll just add 5 to it, you give me 3. So that one is what? 6k is congruent to 3 in mod 5. And now we know that 6k, we are working in this equation here, we are working in mod 5, right? Now 6 is congruent to 1 in mod 5, because when we divide 6 by 5, what's the remainder? I think the remainder is 1, right? So 6 is congruent to 1 in mod 5. Now, since 6 is equals to 1 in mod 5, I can just confidently replace this 6 by 1 here and have k directly. So doing that, I have my k should be equals to what? 3k plus 5. K is congruent to 3 mod 5. Now, rewriting that using division algorithm. So this 3 is a remainder when k is divided by 5. So k can be written as what? 5 times something, which we are going to call n in this case, plus what? Plus 3. That's the remainder. And this n is also an integer, as do not indicate, but it's an integer, same like for all the other constants I've been using there. So if k is equals to this, now I now come to this my solution here and replace the value of k. That will give me what? 6 into what? 5n plus 3 plus 5, and that will give me now 30n plus 18 plus 5. And when you simplify that, you get 30n plus 23. Writing this in a congruence equation, this is a solution to this system. Actually, we are almost done. So the answer here is what? X is congruent to 23 in mod 30. Just write it as a congruence equation. So that is the answer. So the least value. So our final answer is S is congruent to what? 23 mod 30. We are done for the tutorial. Please, I'm begging you, if you are not subscribed to this channel, kindly hit the subscribe button and turn on the notification bell as a reminder, so that when I upload new content, please, you will not be left out. And also, I would like you to drop your comments in the comment section, your likes and dislikes and recommendation, so that you help me to improve. Let me know what my audience exactly want. And if you have maybe some challenging understanding some things, you can also mention them in the comment section, and I'll go through all of them and reply to each and every one of you. Thank you guys for watching, and see you guys in my next tutorial. Bye bye, stay blessed.